Alrighty, so shall we get started? Hello, everybody. This is Alicia Carriquiri from CSAFE at Iowa State University. First of all, welcome. Thanks for joining us today. The webinar today is going to be offered by Professor Keith Einman. Some of you may know him from his 40 plus years of expertise in crime scene reconstruction and crime scene investigation. Keith is currently on the faculty at California State University in East Bay. He has both a BS and an MS in criminalistics from the University of California at Berkeley, and is currently working on his PhD at the University of Dundee. He visited apparently his first crime scene in 1977, and I am sure he doesn't miss that 1 a.m. Phone call to see a scene. Today, Keith is going to talk to us about research and crime scene reconstruction, and we are really thankful at CSAFE that he's going to be making this presentation. Without further ado, happy holidays to everybody, and check our website for news and happenings, www.forensicstats.org. And I think we'll just pass control to Keith. Thanks, Keith.
Well, thank you, Alicia. It's both a pleasure and an honor and a privilege to be able to talk to you today. I welcome everyone from around the world, wherever you might be. Good morning, good afternoon, or good evening. Do I have control? I'm sorry to have to ask that.
You are able to share your screen.
Yes.
Oh, so I have to do that. I'm sorry. Let's see. So I have to do share. Did we make it?
Yes.
Okay, very good. So what I would like to do today is to talk a little bit about the purpose of a crime scene examination, as well as the purpose of a crime scene reconstruction, and those are really not the same thing. I'm going to really start by doing a little bit of history. Apologies to those for whom this may be old stuff, or if you've lived through it. If not, from my perspective, it's useful to know the history so that we know why research is proceeding the way that it is and how we might actually add to it. And so that's where I'll talk about the forces that shaped the work that we currently do and that we might do in the future. That really then becomes the rationale for our research, or what I will suggest could be a direction for research in crime scene reconstruction. That will entail that we look at what the current paradigm is for both research as well as practical crime scene reconstruction, and that leads to the suggestion for additional, and I want to emphasize not a different, but things that we could do that would supplement what we're currently doing. And so I will suggest that there's more to the paradigm than what seems to be present currently, or what is taken to be the current paradigm. And part of that will be to suggest that we start looking at how evidence arises at a crime scene, and to do a little bit more than breaking a window in a laboratory or throwing some blood around. There may actually be more that we need or could do to understand what it is that happens at violent events. And where that leads me is to the creation of a crime scene theater, where a lot of this research really could be done. In particular, rather than looking ahead, this research really would try to, its aim would be to predict what we might find with certain kinds of acts of violence, and therefore guide our investigation during a crime scene exam so that the reconstruction is actually more effective. And that leads to how the scene examination itself might be different. So let's start at the very beginning, or at least what is the nexus of our work, and that is a crime is committed. And the crime is really just some action or an action that is not taken that will constitute an offense, and that offense would be prosecuted by the state, punishable by law. It's something that the state finds unreasonable and really wants to know whether someone should be prosecuted as well as punished for it. When that event is discovered, then an investigation must occur. And in particular, and it's important that we recognize the key part for any investigation is that all of the elements that constitute the crime must be proven in some particular way. And if it weren't for the law, and in particular the specific elements of the law, frankly, we wouldn't have a job. There would not be forensic science if the law really didn't have or require some assistance in proving any of the elements via some scientific investigation. Of course, the investigation includes identifying the person responsible. That only makes sense. But we also want to know really what occurred as part of the action. And so in an attempt to figure out who is responsible for a particular set of actions, science has been invited, if you will. That's the phrase that I like to use. Science has been invited to assist with that particular process. I'm going to talk a little bit more about the goal of forensic science, but certainly right now the goal of any investigation is, as I say, to identify any evidence that would be relevant to a specific offense and bring it to a prosecuting officer. For those of you who actually have been to crime scenes or know anything at all about investigation, there's an enormous amount of information that is uncovered, but typically only a small fraction of that is presented at trial. And so part of the difficulty that we have is really to not only find the physical evidence, but try to identify those objects that are related to the event in question, and to also identify those objects that seem to have no relationship to the event. And that is not a trivial task. If I were to ask you to just look around the space that you're currently in and say, imagine that some crime has occurred right in that space, and then asked you, what is relevant, you would find that it's a much more difficult task than it sounds like. Yeah, if somebody is stabbed and bleeding, it's a little obvious that the blood is good evidence, and the evidence might be, or I'm sorry, the blood spatter might be relevant as well. But there might be several other kinds of evidence that we either don't see or don't recognize. But there's also an enormous number of objects that have nothing to do with the crime that might have taken place there. And so, as I used to tell my friends at the sheriff's lab, we get the medium big bucks for deciding what not to do, as well as for what to do. So I do want to talk briefly about what I have come to believe is the purpose of a forensic science examination, to put it in the context of the kind of applied science that we do. And for those of you who might be intrigued by this photograph, it's actually very early photogrammetry. It's a 1919 homicide in New York City. And it's done in such a way that you can accurately measure everything in that photograph because of the way the photo was actually taken. Setting that aside, the purpose of a forensic science exam is to obviously find some legally important and also useful information about that act. But here's the key part for me, that forensic science is an attempt to reconstruct the past. There are other scientific disciplines that do this as well. Archaeology, some kinds of anthropology. And so forensic science is certainly not alone, but it does mean that there are certain kinds of thinking that occurs and some thoughtfulness that goes into it. And the key to that, to be able to reconstruct the past, is to be able to generate some sort of expectation of what we would say today, right now, at the crime scene, if the event had occurred as proposed. And in order for that to work properly, we have to explicitly formulate our hypotheses, or scenario, if you like that word better. You know, what is it that happened? And it does have to be very detailed and very explicit. If it isn't, if it's very general or generalized, then we're really not going to find anything of value that could support it, because anything general is just too vague. And that's very difficult when you're at the crime scene. In order to do it, however, you do need to use everything at your disposal. Your system one thinking, you see something and what's the first thing that pops into your head? What story runs through your mind? Some prior experience. You know, if you're a firearms examiner, you have an expectation of how a projectile might move through a person, through a wall, things of that sort. We have our preliminary observations, and then we have that thought process. What is it that we see and how do we put it together? That all goes into the hypothesis formulation at the scene. For those of you who are actually concerned now about cognitive bias or any other sort of bias in forensic sphere, I will say that there's a great answer to that. It's an hour or two other kind of discussion, but now is not the time to try to be blind. That's for another time and another kind of, or another part of our examination. But here we need to know absolutely everything in order to be able to, one, formulate explicit hypotheses, and two, formulate alternates, which we also have to do. And in terms of the forensic pursuit of crime scene reconstruction, we will use all of the evidence to infer these sorts of things. We want to know the relative time that a whole bunch of contacts took place. If possible, we want to know the absolute time of each contact as well. And we want to know the relationship of whatever evidence we have uncovered to the crime alleged, the very specific event in question. These are incredibly ambitious. Sometimes absolutely none of them can be achieved, but this really is the goal for the scientific, well, for any sort of reconstruction using testimonial as well as physical evidence. But in terms of science, this is where we want to head. So I want to pause a little bit, having sort of laid out where we should be headed with any specific investigation. And I want to reflect a little bit on those 40 years that, that Alicia referred to, as to where we seem to be today, both in terms of crime scene reconstruction for specific cases, but also crime scene reconstruction as a research endeavor. And for me, we really do go back to the mid-60s to the mid-70s, that time when my generation turned to drugs. And all of that was highly illegal at the time. And in order for law enforcement to keep up with the ever-growing drug use within the country, lots of arrests were made, and the laboratory was essential in prosecuting those cases, because they basically had to know, what drug do I have when I confiscated it from this particular individual? The problem with that is that the labs were overwhelmed with work. I mean, the caseload just went up almost exponentially. And no one thought that the lab actually needed any more people, any more instruments, any more anything. And so there was no increase in resources at all. And in a fairly short period of time, relatively speaking, the analysis of solid dose drugs just took over. And even to this day, the kinds of figures that I see is that 80 to 85% of the workload of any public laboratory is solid dose drugs, which is pretty amazing. What happened as a result is that for those cases where the detective needed some help identifying the perpetrator, the lab could no longer be counted on because many lab managers, and I think I would say most, basically decided that unless your case has a named suspect, in other words, unless you've basically arrested someone, we're not going to do your case. And so only named suspect cases were allowed into the lab for examination of things like fingerprints, tool marks, any biology, trace evidence. Now, one of the exceptions was fingerprints, because obviously you could search the APHIS database, although that was just getting going in the 60s and 70s. Nonetheless, lab managers really had to cut down significantly on the number and kinds of cases that they would let in that were not drug related. And so the role of the forensic laboratory became primarily that of assisting in the prosecution of a case. A case would come in, it had a suspect, and the evidence then would be examined. Otherwise, it just goes on a shelf and nothing happens. Into that really interesting narrowing of both cases done and, unfortunately, the demise, not the demise, but certainly the diminishing of trace evidence, a paradigm was proposed for our work. And that's, it was not called a paradigm, that's the word that I'm using. And in fact, there were actually two paradigms proposed at approximately the same time, separated by perhaps a year. The one that came to predominate throughout most of the forensic science world is known as a hierarchy of propositions. And most of you who have heard of that will recognize this as having basically three levels to the hierarchy. The lowest is really the source, an inquiry as to who or what may have left a particular item at the scene. So what shoe made this shoe print? Who left this particular blood stain? What weapon fired this bullet? Those are all source questions. The second level in the hierarchy was dubbed activity level inquiries. And the question really evolved around what sort of activity resulted in the evidence that we see. So it's not the source, not who was it, but how did it get there? And you can sort of, I think you can look at these basically as the question of association. Were these two objects in contact with one another? And if so, some reasonable inference can be made about the activity that brought them into contact. And the third one, that for the most part were dismissed by the early authors of this paradigm, the event level, was what act really constituted an illegal act. And for the most part, I think individuals think that that's for a jury to decide. And so source and activity level questions can be addressed by science to some extent. But the last one, is this an illegal act, is something for the trier of fact. At the same time as technology advanced, more sophisticated instrumentation started coming in to labs themselves, expertise increased. There was a continuing belief that eyewitness accounts are troubling, that, and especially as more psychological research has been done, people can really be fooled and wrong, even if they have a very high level of confidence in what they're relating as to what they experienced or what they saw. And that meant that as that became better known within legal circles, people turned more and more to science to try to bring more evidence for any particular criminal or violent event. And so you see people turning to science more and more, not people, but law and law enforcement turning to science in order to help them do their job. For a long time, courts have had a criteria for the admissibility of scientific evidence, but it became more focused in the 80s and 90s and resulted, at least in the US, in Daubert hearings and the criteria for admitting any sort of scientific evidence. What's important about that is that laboratories really started analyzing most of their evidence in pursuit of a legal prosecution. And so there was much less analysis on evidence discovery and investigative leads. The key element there is that psychologically it turned laboratories into being very concerned about whether their analysis would actually stand up to legal challenges of admissibility, and not so much on what kinds of tests might we do that would help us discover evidence and provide investigative leads. Now, there's lots of evidence to examine and too few analysts to examine it. So I'm sure you can see that the vice is really closing in here. There's lots of demand, very little resource. And that meant that we started looking at just that evidence that would lead to a conviction, as opposed to sort of stepping back in the investigative process as to what it is that we might actually want to look at. In other words, very few people were actually asking whether we were collecting relevant evidence at the crime scene. More and more, it's left to either detectives or CSI individuals, that is crime scene techs, who have a little bit of science background, but for the most part are not lab geeks doing the tough analytical stuff. So what that means is that a lot of the research, and certainly now, is geared towards validation studies that are designed to meet court admissibility requirements. And without talking too much about all of that, the goal of such validation in the admissibility is a safe conviction, which is to say that the analysis and presentation of physical evidence is appropriate, it's conservative, it can be sustained, that is defended properly, so that any conviction that relies on physical evidence is safe. We're not going to have cases overturned because of, scientifically invalid tests, things of that sort. So the forensic science community really did give into that. We need to do validation on all of our tests so that we can get it into court. And I will just say, as a minor soapbox here, that's a little bit too bad, or maybe very too bad, because it means that we have become very focused on one area where forensic science might contribute to criminal justice, but it's by no means the only one. And I'm not even sure that it's the most important one. So there's now lots of research on analyzing evidence, but there's really not much research. And I actually did a scholastic search before I logged on. It's your morning, my afternoon, to see, well, what is the latest that's happening on crime scene reconstruction? And the answer was just about nothing. And certainly nothing about the kinds of physical evidence that might be produced during different kinds of violent events. Beating with blunt objects, stabbing, strangulation, shooting. What happens when those events occur in terms of the kinds of physical evidence that might be created, more than, for example, bloodstain patterns. Certainly, bloodstain patterns has been a how did this get here kind of discipline, and therefore is a little bit different than the source kinds of questions that many other types of research has focused on. So, is there any research on crime scenes? There is a reasonable amount on processing the scene and presenting or depicting the scene. So a couple of examples that I did pick out from the search that I did just recently, Crime Scene Reconstruction, and that's their title, Reconstruction, but it's not really a reconstruction in the way that I mean it. Using time-of-flight cameras, it's actually in archive.org, and although there's a lot of laser scanners in use now, there are other ways to do it, and that's really what they were pushing. And you can see that their solution is a way of documenting the crime scene. On the left, you have sort of an overall, slightly bird's eye view. Maybe it's a fly's eye view on the side of the wall, and on the right-hand side, there's a close-up, and it's a way of really documenting what is present in a scene. Here at the University of Dundee, Roy Muty and his colleagues are working on augmented reality. They presented this in a poster at the European Academy of Forensic Science. And augmented reality is the combination of sort of your ability to manipulate digitally something that you see through a camera. And so this is a photograph of what could be a crime scene. This is actually a mock-up, obviously, but superimposed on that is some some augmented reality capabilities. You can see that there's some information about the outline of this body. You can very carefully and precisely locate any piece of evidence within this scene, and you can update it hours, days, weeks, or months later as you get more information from analysis. Here, for example, they're interested in the possibility of fingernail scrapings. It's documented at the crime scene as the clippings or scrapings are taking at autopsy and then moved on to analysis, perhaps for DNA or trace evidence. You can update the information about this specific piece of evidence and always bring it back to the crime scene itself. One of the really interesting parts of this is that someone at a remote station can actually log in and see what's going on and either direct the action or oversee it, so that if somebody wants a particular kind of evidence, they can actually instruct the crime scene personnel to take it. So there's some really cool stuff that's happening in the documentation of crime scenes. The question, as far as I'm concerned, is that all there is? Not to cue the song, but really, don't we want to know a little bit more? And in particular, my focus is, shouldn't we be focused on discovering evidence that's just not obvious? Is there something, particularly a way of thinking or another paradigm, that would help in expanding the vision of our research so that we are much more about trying to discover evidence as much as we are analyzing it in a way that's useful either for an investigative lead or prosecution? So if we had something in our world that helped us consider or talk about how evidence began or originated, then I think we're moved along a little bit in the way that we can start to think about research and help this process of reconstructing the past. So I will bring up one of the other paradigms that was presented back or proposed back in the very late 90s, early 2000s, and also as a pot boiler, just sort of put out there, that Shannon's information theory, Claude Shannon, from a paper back in the very late 1930s, early 1940s, and basically invented the internet, would actually be a very useful model as well. I'll cover both of those briefly just to sort of introduce you to that. This paradigm is similar to the hierarchy. Source is in fact the first level in the hierarchy of propositions. This idea of contact or association is the activity level hierarchy. And this idea of event is the same word in the hierarchy as well. So over here, we actually do have the hierarchy of propositions. But you'll notice in this paradigm, there's a whole bunch more over here. For example, we actually do have the crime scene and the interaction of scenes, witnesses, the perpetrator, and the victim. But we also have something going on over here. Transfer, all forensic scientists will recognize as a Locard contribution. Divisible matter is something that was proposed back in the early 2000s as a way of assisting us think about how evidence originates and therefore is carried forward, transferred, if you will, during the commission of the crime, and then during the process of forensic science, which is what we have on the right, helps us understand things about source and things about contact. Very briefly, Shannon really talked about the transmission of information, and I really do think of the physical evidence that we're looking at as information that has been transmitted to us after the event has occurred. And just using one type of evidence, a shoe print, there is a shoe at the crime scene. The transmitter here is actually some soil. The shoe steps into the soil, and at some later time, so therefore a shoe print is made. At some time, this shoe print in sand is perceived, and in between, we have noise, and that noise will serve to deteriorate the information that's imparted from the bottom of the shoe into the sand. And clearly, this impression in the sand is not the same as the shoe print. There is some information missing. And if it goes further, a cast is made, it's pretty clear that they're not the same. And yet, what we try to do is to infer this as the source based on looking at some information that we receive at a later time. And so I think, just as I say, a potboiler for anyone really interested in high-level math and modeling, this I think has an intriguing possibility for as a way of thinking of a universal way of thinking of all physical evidence, that it's the transmission of information from the crime scene forward from a physical item. So you are at the crime scene, and for the most part, you'll stand, at least this is what I used to do, I would stand in the middle of the crime scene, I'd look around, and I would sort of look ahead to what might happen in the laboratory, and I ask, well, what do I see here that will help me understand what happened? What I think would be a very interesting tack to take here is, metaphorically, let's stand at the crime scene and look backwards. Let's look back to the crime event, if you will, and ask, what would have been created in terms of physical evidence during the event itself? Or, to put it into the expectation mode that I talked about earlier, what expectation would I have if X happened? That's one hypothesis. Or what expectation would I have if Y happened? And to look proactively in the crime scene to see if that expectation is met or if it is not. Now, what might that look like in practice? And here's a crime scene. This woman has been bludgeoned to death about the face. And so we have multiple blunt force injuries to her face. It's, clear hypothesis she's bludgeoned to death. That leads to the prediction. We would expect numerous bloodstain patterns, and we would expect lots of blood. And this is what this is very intuitive System 1 storytelling to ourselves. And sure enough, we see bloodstain patterns here on the wall. We have an enormous amount of blood. And this is obvious stuff because we see it. But really, that's just an obvious example. And now I don't know why that didn't come up right, so that's some problem here. But the important point from my perspective is that's only some idea of the range of evidence that would be created during, as we might call it, a prototypical bludgeoning. And so one other question we might ask is, would we expect the instrument to have struck one of the walls? And if so, how often? And should some trace of the wall be found on the instrument? How long would such a trace be expected to persist? What factors would cause it to be lost? What factors would lead to its degradation, that somehow make drywall look different once it's on a bat or some other instrument than it would just if we scraped it from the wall? Time, exposure to chemicals, things of that sort. We might also have another kind of prediction. That amount of bloodshed might result, in fact, in a very bloody assailant. Not always, but certainly that's a reasonable prediction based on what we see at the scene. And so what we might do then is search for transfer from the assailant. And on the left, what you have is what amounts to a bloody palm print on a door jamb. They find that. And so we find that bloody print. The prediction then, if we've done our work, is that bloody prints are, I'm not sure about frequently, but they certainly have the capacity to be a reverse print. That is, furrows look like ridges and ridges look like furrows. And so while the print when examined might look like what's on the left, when you actually reverse it, and you can do that digitally, the traits actually reverse. What looks like a ridge here becomes a furrow here. And this is from a real case. The perpetrator escaped detection for close to 20 years until somebody actually, and this print was discovered and looked at very early in the investigation. And it wasn't until somebody, as I said very much earlier, had the experience to know, you know what, sometimes bloody prints are reversed. So let's go back and look at our suspect pool. And sure enough, the suspect had been known all along. So this sort of perspective asks us to try to do some research that would predict what evidence would be found, and not just use our common sense or common nonsense or the mythology that we have in our brain. Let's actually do some work. It would be very useful to conduct some research on what physical evidence is produced during a violent criminal event. And I call that the origin of physical evidence. The way that that could be used in practice, having done some of it, is that from our initial observations, we could propose a hypothesis for the event, inquire of some intelligence database, hey, what do I expect to find here, and where do I expect to find it, and get an answer back. And then we could go look for that specific kind of evidence. So we're interested in the dynamics of what and how physical evidence is produced and dispersed during any act of violence. It would be research that would look not only what could be produced, but where it might be deposited. And if we're really good in this day of artificial intelligence and games and models and things of that sort, eventually we should be able to model how much of any evidence could be produced based on what we see. And we should have some sense of how long that evidence would persist, what would lead to it going away, and any changes that it might undergo given the sun, the rain, the heat, the ultraviolet light, things of that sort. The decay or degradation of evidence would be an integral part of that because we face it all the time. How long would we expect fibers to persist in a particular area? Is it an hour? Is it 3 hours? Is it 5 minutes? Is it 2 days? That range would be very useful to know, especially if we can get some idea of when the event occurred. What factors would produce degradation? How much of the individuality is lost? And so the source question becomes complicated or ambiguous as well. When such research is used properly, then at the scene, multiple hypotheses can be formed and various kinds of searches can be performed over a wide variety of types of evidence, not just the blood stains that we can see or the knife sticking out of the person's chest, but the stuff that has, all but disappeared. What about the trace evidence, the small stuff that everybody overlooks? And what that research would do is to contribute to that predictive element. And that is currently what is missing from a science perspective. And the goal would be for more relevant evidence to be collected at the scene so that later inferences can be narrowed. We keep the reasonable ones, we reject the ones that are unreasonable. I think one of the great values of thinking about evidence in this way, and particularly at the crime scene, in an attempt to do a crime scene reconstruction as an investigative lead, is that any degree of uncertainty is perfectly adequate. I don't care if it's 10%, that's fine, as long as we understand how to integrate a 10%, a belief of 10% into the totality of the investigation. And I will say, from my 40 years of experience dealing with detectives, that they're actually pretty good at balancing the uncertainty. I don't think we've been particularly good at communicating uncertainty to detectives about our work, but when we do, they're very good, I think, at not ignoring things that they should not ignore. And that phrase I won't read, but frankly, it's usually a little bit better than what we say. There really would be more science in saying that there's a 16% chance that the person has blue eyes. That really is more scientific than phrases like consistent with, things of that sort. I'm pretty sure there's something to offend almost everyone in my talk here, by the way, for those of you who believe in consistent with. Now, how does all of this happen in trying to run downhill in terms of my time here? I think the most fascinating thing that we could do is to create a crime scene theater, a place where all of this research could actually be done in a way that would give us the ability to have an intelligence database and to be predictive with some level of uncertainty associated with it. It would have high-speed still and video cameras, sensors that would be capable of detecting a range of applied forces. How strongly do you have to beat on somebody before something happens? You would need something that would reproducibly produce some energy for the stabbing, beating, or whatever violent event you might want to consider. I think sound sensors would be fun to have as well, so that you can get an idea of anything from bumps to gunshots. And you'd want the walls to expand and contract so that you could make the room a variety of different sizes. What you would want to do in this theater is to take one particular kind of violent act and do it repeatedly over and over again. And every time that it's repeated, it's recorded. And the computer gaming people have this down to more than a science, pardon the expression, but they do this for a living. And they know how to record and digitize all of those movements. And then the best part about it is we get to bring in the math and computer people and say, let's do some modeling. And obviously, it's quite interdisciplinary. I've listed a whole bunch of people that typically or disciplines rather, that are typically not involved in forensic science work. And there's one at the end that I want to suggest that I think is very interesting as well. Continuing on with that multidisciplinarity part of it, we need people from chemistry, from physics, that's obvious, mathematics and statistics, obviously computer science. But the most fun would be to get the theater and the drama people involved. An actor or actress they hone their craft so that they can do exactly the same thing time after time after time, that they do it in precisely the same way. And so being able to invoke those people, and especially the ones who are good at scenes of violence in plays, that you get them to reenact a violent act over and over. And they can do it the same, as close to the same way as possible every time, so that you minimize the variation by how it's done, and you think about the variation of the dispersion of evidence itself, minimizing the repetition. The value of all of this is you produce what I like to call a horizon of expectations for any sort of hypothesized event. You don't expect 100 fibers to be in a 2 square foot area 50 feet away from the violent event. And that's just an obvious one. But when you do it over and over, you can actually narrow that horizon of expectations down. And if we do that, then what we are essentially doing is directing our attention to searching for the evidence that we expect based on the information that we have there. Now, of course, the problem there is that if you start getting tunnel vision, you're gonna miss stuff, and you could be completely wrong. So you don't look at one particular scenario and say, I'm only gonna look for this. You hypothesize several, and drawing from the statistics and mathematics communities, you would say at some point you have a completely bizarre one that you think couldn't possibly happen, and sort of look there as well, just to make sure that you're not so focused you've missed something that is otherwise hidden. Right now, if all we have is fingerprints and DNA and maybe firearms, we're just too limited, because there's much more evidence being created at a violent event than we're collecting. And so the more evidence that we find, the more likely we are to actually find the correct hypothesis. And I don't mean correct in the sense that we ever know that with finality, because all hypotheses are provisional. But the more evidence that supports one to the exclusion of others, the more we, as I say here, are approximately correct, or we get closer to the truth, whether we know it or not. Now, the expectations could include the production of the evidence. Sorry, this goes back to the paradigm. The production is basically divisible matter, how material is actually made, the nature of evidence. And so we understand how it fractures, what characteristics we might expect there, and how things might acquire traits that are unusual. I won't use the phrase unique, but unusual. We could then develop expectations about the dispersion of that evidence, and think low card there, how long it might persist, whether it would degrade. The validation of that model is really different. It has a different goal than the validation of methods for court admissibility. I think I've said enough that courts have a specific set of criteria, and that's not really the goal. It's not as though somehow we want this work to find its way into court. It's used in a very different way. What we want to know is to understand what happened and who was involved, so that other investigative methods or other inquiries can be made that would serve the purpose of legal, being able to admit them into court. What happens is that reliable investigative leads are produced. Now, of course, like every other piece of circumstantial evidence, or like direct evidence, eyewitness IDs, they could lead in the wrong direction. And so training really is a vital part of this. And although I don't think many people would admit it, detectives really do understand inference and balance of probability. They really don't use those phrases, but that really is something that they are pretty good at. And if we explain it the right way, they actually should have a good way to utilize the evidence that we might produce. Now look, this model could fail. I think it's the closest thing to basic science research that we could conceive of for forensic science. And so it's possible that at the end of 5 to 10 years, it wouldn't produce much of anything. But if it did succeed, or even if parts of it succeeded, we would really change the way that crime scenes are processed. We need basic research into finding relevant and legal physical evidence. We need to know how the evidence is generated during a real act of violence, not just a laboratory crashing of a pane of glass, to use that example again. We can model or simulate acts of violence once we have a baseline of that. We can do research in how long things will last and what time constraints are present. It should lead to better practices for evidence discovery and collection, and the generation of probabilistic models of reconstruction that would be based on either repetitive testing or bootstrap models. And that really constitutes my brain dump, if you will, for what research could be, and I think should be, with regard to crime scene reconstruction. Not documenting the crime scene and not presenting it in court, but actually searching it and trying to find out what happened during that physical event. And I think we fade to black at this point. Yes, we do. And at this point, I left 9, not 10 minutes for questions. And I probably need a little bit of assistance in knowing where the questions might be and how I can get them.
Thank you so much, Keith. That was really interesting.